Welcome. This video is for Cambridge IGCSE AS level, CIE AS level, Mathematics, Probability and Statistics 1, Practice Paper 1 for the upcoming examinations. Now, question number 1. A bag contains 9 blue marbles. 9 blue marbles, 3 red marbles. 3 red marbles. 1 marble is chosen at random from the bag. How many marbles I'm choosing? I'm choosing 1 marble at random. If this marble is blue, it is replaced. So if at all it is blue, what am I going it out? I am going to replace it if it is replaced. If it is red, it is not replaced. Not replaced means not returned back. A second marble is then chosen from the bag. Find the probability that both the marbles are red. So the first one and the second one, both should be nothing but what? Red. The first one should also be red and the second one also should be red. So how many red are there? Totally 3 are there. 3 out of total is nothing but what? 9 plus 3, 12. And means times. The second one also should be red. Now because once the first one is red, it is not being replaced. So now 12 will become 11. Now already one red is over, so it will become 2 more are left over. So 2 out of 11. So 3 upon 12 times 2 upon 11, which is 1 upon 22. Find the probability that the first marble chosen is blue, given that the second marble chosen is red. So probability of first B1, given that it is R2. So what should be there? The denominator should be denominator probability of R2 and numerator will be first one is blue, given that the second one is red. Now the second one is red. First I do the denominator. First and second. So first one can be red and second one also can be red. So if first one is red and second one is red, is just now we have done it out. It is 3 upon 12 times 2 upon 11. Or means plus. Or means plus. Now first and second. First one can be blue, but the second one has to be red. So if the first one is blue, it is nothing but what? 9 upon 12. Because the first one is blue means 9 upon 12, then it is not replaced. So for the second one also, I will be having same 12 only, but the second one should be red. Now out of this, which one should be going to the numerator? Where the first one is blue. Which one? This part. This part goes to the numerator. So it becomes 9 upon 12 times 3 upon 12. Simplify by the calculator. You should be able to get this one as 3 upon 16 divided by 3 upon 16 plus 1 upon 22, which is going to be 33 upon 41, which is you can write 0.805. Next, question number 2. Anil is a candidate. In an election, he receives 40% of the votes. So probability of success is 0.4. So probability of failure will be 0.6. A random sample of 120 voters, n equals to nothing but what? 120 is chosen. Use the approximation to find the probability of 120 voters between 36 and 54. So probability of it lies between 36 and 54. So probability of x less than 54 minus probability of x less than 36. Now this is x less than 54. When I'm taking it out, it should be taken as z less than 54.5. Because of approximation, we are using 54.5 minus mu. What is mu? 48 by sigma square root of 28.8 minus probability of z less than. For this one, I should be taking it as 35.5. Anything less than 35.5 minus 48 by square root of 28.8. So remember that for the upper limit, I am going to take 54.5 because of approximation, and for the lower limit, I should be taking 35.5 because it lies between 36 and 54. So if this is a number line, this is 36 and this is 54. Now anything here 54.5 and over here 35.5. Now this entire thing between this entire thing is lying between 36 and 54. So therefore you have to be very much careful for taking 54.5 and 35.5. Now I use the calculator to get probability of z less than. This becomes 1.211 minus probability of z less than negative 2.3292. Now probability of z less than 1.211 minus, whenever you're converting negative to positive, what are we supposed to do? 1 minus probability of z less than 2.3292. Then expand this one. Probability of z less than 1.211 minus 1 plus probability of z less than 2.3292. Now substitute these values. So what am I going to get that one? So I am going to get this values as, if at all you see from the calculator or the table, 0.8871 plus 0.9900 minus 1, which will give you 0.877 in three significant figures. This is going to be the answer. So coming to question number 3, the following back-to-back stem and leaf diagram represents the monthly salaries in dollars of 27 employees of two companies A and B. 1/27/6 indicates 2710. So just add a 0 for company A and 2760 for company B. Find the median and interquartile range for the company A. So median. So the middle term, there are 27 plus 1 by 2, so which is 28 by 2, which is going to be the 14th term. Which is the 14th term? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the 14th term. So it's going to be $2710. Now we know that 14th term is in the middle, and over here on the left hand side I have 13 terms, and on the right hand side I have 13 terms. Now the middle term for this one is going to be my Q1. So 13 plus 1 by 2, which is to 14 by 2, 7th term. So the 7th term is going to be the middle term. So this one was our Q2. Now the 7th term. Calculate the 7th term. 1, 2, 3, 4, 5, 6, 7. So 2610. So Q1 is 2610. Now coming for the, on the left hand side, again 13 plus right hand side, 13 plus 1 by 2, which is the 7th term. 7th term from Q2. 7th term from Q2. 1, 2, 3, 4, 5, 6, 7. So which is 2840. So dollars 2840. So what's going to be the interquartile range? Interquartile range is Q3 minus Q1, which is 2840 minus 2610, which is going to be $230. The lower quartile, median, and upper quartile of the company B are given. Draw the box plots. So first of all, what am I going to do it on? I am going to write the values for both A and B. So for A, minimum value 2500, lower quartile 2610, median 2710. So I will write it out over here so that for A, the minimum value is 2560, lower quartile is 2610, median, then upper quartile, and then the highest value. Whereas for B, minimum value is 2540, lower quartile 2600, then median, then upper quartile, then the highest value. Then I am going to draw the box plot for that. So for that I should be taking the proper scaling, otherwise we will not be able to get that. So let me start the scaling with, because we know that lowest value is 2540. So, and highest is going up to 3100. So if at all I use this one as 2500, 2600, 2700, 2800, 2900, 3000, and 3100. So everything is covered. So, and over here, this is nothing but what? Salary in dollars. Salary in dollars. So now for A, let's start with A. 2560, 2560. 560 will be in the middle over here. So we can see 2560, 2610, 2610, 2610, 2710. Each line is 10. There are 10 lines, therefore each line is 10. 2840, 2840. Then 3010, 3010, 3010. So over here also I erase this and draw 3000, 2500, 2500, 2500, 2610, 710, 840 and 3010. So this is going to be the box plot for A. Whiskers on both the sides. Now box for B. 2540, 2540, then 2600, 2600, then 2690, 2690, 2780, then 3090, 3090. That's the whisker, and this one. So this is for B and this is for A. Comment on whether the mean would be a more appropriate measure than the median for the comparing the given information for these two. So what is the thing is mean is less appropriate. Why? Because it is being affected by the outliers. Mean is less appropriate. Mean is less appropriate than median. Remember, everything this time is the standard question. Mean is less appropriate than median because the extreme value for company B. Company B has an extreme value of 3090. So that's going to be the answer. Question number 4. A mathematical puzzle is given to a large number of students. The times taken to complete the puzzle are normally distributed with a mean 14.6 and a standard deviation 5.2. If a random sample of 250 of the students, how many would you expect to have taken more than 20 minutes? Probability of x greater than 20. So probability of z greater than 20 minus mu is 14.6 by 5.2. So this becomes probability of z greater than 1.03846. So 1 minus probability of z less than 1.03846. So 1 minus 0.8504, which is going to be 0.150. But how many students are there? 250 students are there. So total number of students equals to number of students will be equal to 250 times 0.150, which is going to be 37. Next, all the students are given a second puzzle to complete. Their times in minutes are normally distributed with mean mu and standard deviation sigma. It is found that 20% of the students have times less than 14.5 minutes and 20% of the students probability of x less than 14.5 equals to 20%. So probability of z less than 14.5 minus mu by sigma equals to 0.2. But this value is not there in the table, so I convert into 1 minus 0.8. So we swap this one. Probability of z less than mu minus 14.5 by sigma is 0.8. So mu minus 4.5 by sigma equals to 0.842. Next one, what does it say? 67% are greater than 18.5. So probability of x greater than 18.5 equals to 67%. So probability of x less than 18.5 will be remaining 33%. So probability of z less than 18.5 minus mu by sigma equals to 0.33. But again, what happens is this value is not there in the table. So therefore, we subtract 0.67. So we swap this one. So it becomes probability of z less than mu minus 18.5 by sigma equals to 0.67. So mu minus 18.5 by sigma equals to 0.44 from the table. Now I got two values, so divide both. Mu minus 4.5 by sigma divided by mu minus 18.5 by sigma equals to 0.842 divided by 0.44. So sigma and sigma gets cancels. So mu minus 4.5 divided by mu minus 18.5 equals to, when I take the calculator and divide it out, 0.842 divided by 0.44 should be giving me 1.9136. Then do the cross multiplication and get the value of mu. I am directly writing over here. You should be getting mu value as 22.9. Now what am I going to do? I am going to plug in this mu value over here. So 22.9 minus 18.5 by sigma equals to 0.44. So sigma equals to 22.9 minus 18.5 divided by 0.44. This should be giving you 9.95. So we get the value of sigma, which is 22.9 minus 18.5 divided by 0.44. This should be equals to 9.95 or approximately equals to 10. Now coming to question number 5. A game is played with an ordinary fair six-sided die. The player throws the die once. If the result is 2, 3, 4, 5, that the result player that result is a player score. If at all it is 2, 3, 4, 5, that is the score. So if at all it is 1, something else is being done. If at all it is 2, that is a score. If at all it is 3, that is a score. If at all it is 4, also that is a score. If at all it is 5, also that is a score. 5 also it is a score. But and does not throw the die again. If the result is 1 or 6, he throws for the second time, and score is the sum of the two numbers on this one. So whenever he gets 1, so again he throws for second time. 1, 2, 3, 4, 5, and 6. So he can get 1, he can get 2, he can get 3, he can get 4, he can get 5, he can get 6. Now, if at all he's getting 6 in the first time also, 6 in the first time, then again he will be throwing for the second time. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Now, what is the probability? Individual probability. This is 1 upon 6. This has to be 1 upon 6, 1 upon 6, 1 upon 6, 1 upon 6. This is also 1 upon 6. Same again, every probability is 1 upon 6 because it is a fair dice. 1 upon 6, 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 and 1 upon 6. Draw the diagram. Then event A and B are defined as A scores 5, 6, 7, 8, 9. A scores 5, 6, 7, 8, 9. And B, the player has two throws. Probability of A equals to 1 upon 3. So we have to prove that the probability of A is 1 upon 3. So how should I be proving it out? So 5. How do I get 5? How can I get 5? I can get 5 as 1 plus 4 or only 5 in the first throw. So 1 plus 4 is nothing but what? 1 upon 6 times 1 upon 6 or 1 upon 6 only. which is 7 upon 36. He can get a 6. How can I get a 6? Just only from 1 plus 5, which is 1 upon 6 times 1 upon 6, which is 1 upon 36. Then he can get 7. How he can get 7? 1 plus 6 or 6 plus 1. So which is 1 upon 6 times 1 upon 6 plus 1 upon 6 times 1 upon 6, which is 2 upon 36. Then he can get 8. How he can get 8? 6 plus 2. So which is 1 upon 6 times 1 upon 6, which is 1 upon 36. Or he can get 9, which is 6 plus 3. 1 upon 6 times 1 upon 6, which is 1 upon 36. So probability of A is going to be, add them all, 7 upon 36 plus 1 upon 36 plus 2 upon 36 plus 1 upon 36 plus 1 upon 36, which is 12 upon 36, which is 1 upon 3. Determine whether the events A and B are independent or not. So probability of A, just now we got 1 upon 3. We need to get probability of B. What is B is talking about? The player has 2 throws. When can he have 2 throws? Either on 1 or 6. So which is 2 upon 6. 2 upon 6, which is 1 upon 3. Now probability of A intersection B, I find it out. Probability of A intersection B means, what is the meaning? He has 2 throws and he should be getting it out. 2 throws and these numbers. 2 throws and these numbers. 2 throws is nothing but 1 upon 3 and one of these numbers. These numbers is nothing but how much? And these numbers. He should be able to get it out. What are those? When he's doing 2 throws over here, 1, 2, 3, 4, 5, 6. 6 times are there. When he's doing 2 throws and getting 5, 6, 7, 8. So P of A intersection B is 6 upon 36. So for being independent, P of A intersection B should be equals to P of A times P of B. Check that one. This is 6 upon 36. Is it equal to 1 upon 3 times 1 upon 3? No, it is not equal. So therefore, not independent. Not independent. Find the probability of P given A complement. Probability of P given A complement is denominator probability of A complement. Numerator is probability of B intersection A complement. Probability of A complement means not getting A. Not getting A is, getting A was 1 upon 3. So not getting A is 1 minus 1 upon 3. B intersection A complement is nothing but what? Same, 6 upon 36. 6 upon 36. So it is 6 upon 36 upon 2 upon 3, which is going to be 1 upon 4. Question number 6. Janice is playing a computer game. She has to complete the level 1, level 2 to finish the game. She is allowed at most 2 attempts. For level 1, the probability she completes the first attempt is 0.6. Then and if she fails her first attempt, then the probability she completes in the second attempt is 0.3. So which is going to be 0.3. After that, what is being asked over there? It has been asked that if Janice completes level 1, she moves to level 2. For level 2, the probability that she completes the first attempt is 0.4. She fails in the attempt and that she completes the second attempt is 0.2. Show that the probability moves to level 2 is 0.72. When she can move to level 2, so if at all level 1 is done, or what will happen? Level 1 is not done and what is this? In the first attempt, level 1 is not done in the first attempt, it is done in the second attempt. Then she completes the, so let me draw it out like this rather than doing it out in that way. So level 1 and level 1 complete, level 1 not complete. Level 1 complete is nothing but what? 0.6. If she fails the level 1, which is 0.4, then she completes it the second attempt. She will go for the second attempt for the level 1 complete, and level 1 not complete. Level 1 complete will be 0.3, not complete will be 0.7. Now, if Janice completes the level 1, she immediately moves to level 2. For level 2, so she moves to level 2. So this is not required for this one because I want to only going up to level 2. She moves to level 2, then she completes it in the first attempt. Level 2 complete, level 2 not complete. Level 2 complete is 0.4, not complete is 0.6. Then first attempt is 0.4, and if she fails in that first attempt, the probability that she completes it in the second attempt is 0.8. So then again she plays it for the second attempt, level 2. Level 2, level 2 complete and not complete. Complete in the second attempt is 0.2, then this should be 0.8. Now level 2 complete in the first attempt, level 2 not complete in the first attempt, 0.4, 0.6. Then again over here for this one it should be again level 2 not complete, level 2 complete, so which is 0.2 and 0.8. This is a Venn diagram or the tree diagram. Show that the probability that she moves to level 2. When can she move to the level 2? When she completes level 1, which is 0.6, or over here she goes to the level 2. So which is 0.6 plus 0.4 times 0.3, which is 0.72. Find the probability that she finishes the game. When she finishes the game, so if at all she completing the level 2, if she completes level 2, in what way she can complete the level 2? So first of all, level 1 has been completed, level 1 completed, then and if level 1 is completed and means multiplication, then she go for the level 2. So level 2 is nothing but what completion is. Level 2 completion is 0.6 or 0.4 or 0.6 times 0.2. So which is 0.4 plus 0.6 times 0.2. In this way she will be completing the level 2. This is times. So my final answer is going to be, when I simplify this one, 0.3744 is going to be the final answer. Next, question number C. Find the probability that Janice fails exactly one attempt given that she finishes the game. So exactly fails exactly one attempt. So probability of fails first or second given that finishes. So probability of finishing the game is in the denominator. Finishing the game is in the denominator. So probability of fails first or second and finishes should be there in the numerator. So what should be done? So we know that the denominator is going to be our part B answer, which is nothing but what? 0.3744. 0.3744. Only coming to the numerator, fails first or second and finishes the game. So we go back here, we erase this one, this one, this one, this one. Now she has to fail the first or the second and finishes the game. If she fails the first and finishes this one, so 0.4 times 0.3 times 0.4 is 1. Now, or another way is nothing but what? 0.6 times 0.6 and then she passes. 0.6 times 0.6 times she completes the second attempt. Second attempt for this one, which is nothing but what? L2 completing 0.2. So we can write it out like this. So it's going to be the numerator is 0.6 times 0.6 times 0.2 or 0.4 times 0.3 times 0.4, which is going to be the answer is 0.12 divided by 0.3744, which is going to be 0.321. Coming to question number 7. Find the number of different arrangement of the 9-letter words alligator in which two A's are together. Two A's are together, A, and all the two L's are together. Two L's are together, L. So what am I left over with? IGTOR. So totally this is 1 unit, 1 unit, 1. So totally how many units are there? 7 units. 7 units can be arranged in 7 factorial, which is 5040. The 9 letters in the word in alligator are arranged in a random order. Find the probability that two L's are together. So I'm joining those two L's, and there are exactly 6 letters between the two A's. And there are only 6 letters between two A's. So now what am I left over with? AIGATOR. So A and A. There are only 6 letters. 1, 2, 3, 4, 5, 6, and an A. Now in that case, what should I be doing it out? So how should I be able to get this one? He's telling that find the probability that two L's are together and there are 6 letters between two A's. So I have to arrange 6 letters between two A's. So I have to take two A's are gone. So but I'm left over only with what is it? 1, 2, 3, 4, 5. So what should be there is they should have two L's. One of the two L's should be there, and I should be left over with nothing but what? 4 more over here, and it should be in such a way. So what is that way once again? See carefully. Coming to question number B. The 9-letter words alligator are arranged in a random order. Find the probability that two L's are together. Both the L's are together. So L and L. And there are exactly 6 letters between two A's. A and A. If A and A is gone, L and L is gone, what am I left over with? IGTOR. IGTOR. So what should I be able to do that? How should I be able to do that kind of arrangement? So 1, 2, 3, 4, 5, 6. So if those two L's are there over here, then this two L's is 1 unit, and I use another 1, 2, 3, 4. So totally there are how many units? 5 units. These 5 units can be arranged in how many ways? 5 factorial ways. These 5 units can be arranged in 5 factorial ways. Then after that, what am I going to do that? Once I am arranging these 5 units in those 5 factorial ways, then times 5. From where I got this times 5? Because I have what is one more place left over here. Either over here, it is one more place left over here. So this can be done in 5 ways. And one more place can also be left over here. So this can be done in another 5 ways. So 5 times 2. So it can be either be over here or over here. That extra alphabet because we have used only 4. Already we have used 4. One extra alphabet will be left over. that extra alphabet can be there at the beginning, at the start, or at end. So that's the way. So 5 factorial times 5 times 2. So answer is going to be nothing but what? 1200. Now part C, find the number of different selections, and is it the probability now? Find the probability for this one. So this one was 1200. Number of ways. So we got just 1200, but still we have to find the probability now. So for that, probability will be 1200 by total number of ways, which is 9 factorial by 2 factorial, 2 factorial, which is 1200 by 90,720, which is 5 upon 378 or 0.0132, because it's asking for probability. Part C, find the number of different selections of the 5 letters of the word from the 9 letters of the alligator, which contains at least one A and at most one L. It should contain one A and 0 L, one both the A's and no L's, one A, one L, both the A's and one L. That's all. These are the ways. Now the word alligator. Alligator. So A is gone, A is gone, L is gone, L is gone. So how many are left over? 5 are left over. Now I can fill it out this one in 5C4, which is 5. This is 5C3, which is 10. This is also 5C3, which is 10. This is 5C2, which is 10. So add them all. So this is going to be the answer as 35. So that completes this practice paper 1. See you in the practice paper 2. Bye.